Good afternoon, everybody. Today I will present you our naval architecture and ocean engineering proposal project, which is on subsea hyperloop. First, let me talk briefly about what made us choose this subject among others, and what we found that was interesting about it. First, in 2019, researchers showed that 29% of the greenhouse gas emission was due to transportation. And as you can see in this chart, among all of the other categories, it represents the most important. Other studies and researches showed that the fossil energy tend to deplete among years. So, for example, the oil, it is expected to disappear in Earth, the reserve, in 30 years. And for the gas, it's in 40 years. So for all these reasons, governments and country and global organizations have an objective, which is to reduce the carbon emissions in the atmosphere, which is the current world's most important mission, and they want to do that to 2050. Secondly, the population of Earth is increasing, and according to studies, it won't stop, and in 2050 it will reach almost 9 billion inhabitants of the world. So we will need more transportation because there will be more people, more flow of people. So we will need a new way of transportation for these people. What is Hyperloop? In 2013, Elon Musk presented his Hyperloop new project. Why could it suit the needs that we talked before about the population increasing and the greenhouse gas emission? First, it has ultra high speed transportation. So for passenger and cargos. So for passenger, we have new way of transportation, and it will create more transportation for the people. Secondly, it is an eco-friendly transportation because it uses renewable energies like solar power. I will show you a little video to explain more.
This link. Next up. Yes.
세 살 때 부모님이 이혼을 하셨어요. 오래된 다가구 주택의 반지하 월세로 얻어서 살았는데
Deviating slightly from Musk's original plan, Virgin Hyperloop One's technology combines two basic principles. The first is magnetic levitation, or maglev, a technology already used in monorails to lift the passenger pods and move them along their rails. Magnetic levitation uses two sets of magnets, one to repel the train from the track and lift it upwards, and the other to move the floating train along the track at considerable speed with reduced friction. The second principle is the use of a low-pressure, vacuum-sealed environment for the passenger pods to travel through. By removing most of the air from the tubes and having no contact with the ground, The pods face little to no resistance as they move. Air pressures inside the tube are equivalent to flying 200,000 feet above sea level. Such an environment
You saw that it will eliminate the air resistance. So when you are in a car on the highway and you put your hands off and you see all of the resistance, the force you have on your hand, you can imagine the amount of energy you could save by using this technology. The main goal of Hyperloop is to reach, as you can see, how it's called the zone of opportunity, because every time a new way of transportation were created, it was faster, but it also used more energy. So there is all this zone that this project want to reach. As I said before, there is two applications. The first one is passenger transport. For example, one project is from Washington to New York, and it would take only 30 minutes, where a plane is currently taking 1 hour to 1 hour and 30 minutes. There is other projects among the world in Korea, USA, Dubai, Europe, India, and China. The second application is cargo transports. Using cargo to transport merchandise was a revolution. So using this with the Hyperloop technology would allow us to reach new possibilities. For example, if a company order a big amount of items that they need, the demand could be answered autonomously. So it could be very fast and we could save a lot of time. Then why underwater? Our project is mainly to adapt the system underwater in the ocean. What would be interesting to adapt it? First, this is the next step on the two objectives we talked before. For example, the greenhouse gas emissions. Among transportation, there is not only cars and trains, but also ships and boats. So this is the next step to reduce carbon dioxide in the atmosphere. And secondly, to bypass the problems we have, for example, in airports or in ports. With the Hyperloop technology, it will save a lot of time also. Now, I would like to have a little discussion with you. According to what I said before and what you know, what do you think would be the main problems or engineering problems with underwater Hyperloop? Anyone have like?
I have a question.
Yes.
So, since the Hyperloop underwater will be a chamber that is vacuum sealed, there is no air in the chamber. One problem that I can see emerging is a problem of safety. If by any chance the Hyperloop does not work or it stops midway, do you have any idea of what kind of safety procedures one can follow? Because then they will need to work around the vacuum chamber, and they'll need to work around how people are gonna be extracted or people are gonna be sent to help them.
Yes, that is a a question. I'm not going to answer it, but later we will talk about the main aspects about safety and the problems. Well, thank you for your idea.
That's another question. You said that the Hyperloop chamber is close to vacuum, right? Whereas if you put it underwater, then the water pressure is very high. And the pressure difference between inside the Hyperloop itself and the water pressure from the outside is higher than it is above ground.
Yeah.
So maybe how can you deal with that?
It represents, as you say, more important difference. So this is another aspect that we will treat later. Anyone else?
I'm curious about the cost. You introduced a project connect to New York and Washington. It's on
The project,
yeah, right?
the project actually, there is no really today projects about underwater. The project about Washington was from Washington to New York. But there is also other project in Europe, for example, I don't know which country in Europe, but it's still inland for the moment.
So you said your team's term project is subsea.
To adapt
So
yes.
I curious about cost compared to offshore, onshore.
For example, onshore, I think the first Elon Musk project was about $6 billion, I think. So of course, underwater it will be more expensive, and this is also another problem, which is not an engineering problem, but the problem that we have to be considered. Yes.
If a passenger in the Hyperloop has some claustrophobia, how do you deal with it?
The first project, Elon Musk had an idea which was because we can't have window because of the pressure inside on outside, but an idea was to put a screen instead of the windows and landscapes. To it have to be engineered, but it could be a solution. It was the first solution about what he thought. I'm gonna move on to the next slide. So as you all said, there are a lot of problems that may occur. For example, the first one is the resistance of the structure, which is more complicated more complicated as in the lands, because it has other parameters, the pressure of the ocean, the forces of the waves. So it seems to be more complicated compared to the conventional Hyperloop. The second one is the vacuum hold, as I think said, which has to be maintained even if it's underwater. Then one problem is there is a related to ocean and seas. There is a lot of laws and regulations. For example, in the international seas, you can't build what you want like that. You have to see with the other countries and international organizations. There is also laws about the protection of the maritime environments. So you can't build everywhere on the ocean. So maybe these laws will have to be reviewed to allow companies to build Hyperloop underwater. Then I talked before that this project was to help people have more way of transportation. But for now, all of the prototypes has only few people on board, 2 or 3. So the final Hyperloop will have also to solve this problem. And finally, it's an underwater system, so it will have to bring energy underwater. So will we use inland power plants, or will we use renewable energy or renewable energy of the ocean? That is another question that will have to be answered. There are all other problems, like you said, claustrophobia. Another one, because of the high speed of the Hyperloop, an emergency stop is impossible. So it will be necessary to not have any obstacle in the way. We will need to see how the passengers will go on board, so how which infrastructure will be needed to do it, and also the vibration in the ocean. Our group decided to focus on 2 main aspects. The first one is the resistance of the structure. As I said, there is a lot of forces and pressure compared to onshore, so it will be dealt during this project. And the second one is everything related to the energy for a journey for the Hyperloop. This is the timeline. You can see how it is split for the different presentations. And this is our group with all of the different aspects we will treat each other. Thank you. If you have any question or any other thoughts about it.
I really like the way how you construct the presentation, but you guys really focused on the specific way to handle the problem of the transport system, which really seems to be like future technology. So that was really good for point of your devices presentation. And I checked the 17th slide. Yeah, I think this slide showed the role of the role after the first presentation, like this presentation.
Yes.
So, can you briefly say how you guys how each guys have done for this presentation? How each of you guys done? What is you guys' job for preparing this presentation?
This one. We first made brainstorming about our different ideas, and then we chose this one because we thought that it has a lot of different interesting aspects. Then we made researches, general researches about the first part of the presentation, what is the Hyperloop, and we then wanted to adapt it underwater to fill the this class project. Then we asked ourselves what would maybe be the main problems about this technology, and then we can see on this slide we choose two of them. So we choose these two because I think we could use the lectures to answer these problems, and it seemed good for us to do it, interesting, and that's it.
Well, my lab research structural systems. So I'm very curious about how evaluate resistance of structures.
First, as you can see here, we saw that there were different possible structures. We already find three of them, different structures. So the models will be adapted for every structure, and we will study the forces, the deformations, the stresses, and the structure, and everything about pressure, how could it resist, how thick this have to be, and maybe which material may be used to it.
So you guys have a plan to use structure compilation software like ANSYS or ANSYS.com? Apps like that?
Yeah, maybe. Yeah. We'll calculate.
I think like magnetic like resonance detector or something like that can have a strong dependence on temperature. So although I don't know if you guys are like trying to kind of divide like the region whatsoever, but I think it could also be kind of important to regulate temperature since like it decreases like rapidly with like ocean, also depending on how deep you are going to structure. So maybe do you have those other?
Can you speak louder? I can hear and also protect you.
So should I say the whole thing like that? Yeah, it was like over kind of, but I'll just say it again. So I think like the magnetic resonance effect has a large dependence on temperature. So maybe like I think also the depth, as you like decrease the depth, it becomes like if there's a really like large dependence on ocean temperature. So I don't know like if you are going to like divide the region between like where the passengers are sitting or like the other parts of the rails, but did you ever like kind of consider, or will you consider such kind of like external parameters like temperature as well as like pressure?
For maybe not for the resonance aspect you said before, but for the resistance of the structure, every parameters of the materials have to be considered with the temperature because it change with it. So we will consider it for our study.
I think you guys don't have to calculate temperature because vacuum tunnel temperature don't transfer vacuum tunnel. So I think temperature is okay.
For the external tunnel.
Outer structure, like it's water.
No. Vacuum tunnel, there the hyperloop is in vacuum tunnel. So, but temperature couldn't transfer vacuum. So it's okay. Temperature probably is okay.
But I talked about the external parts of the tunnel.
So
it's in contact with the water. So
but she was asking for the magnetic field inside the vacuum.
I guess so.
the
What I was
outside.
saying was like kind of, are you like thinking of providing like insulation for the whole structure, but for I guess like maybe for like the outer core.
Maybe. We try to not focus on too many aspects and only these two because we wanted to finish the project.
I have a
Yeah.
comment also, caption and comment. One thing is, when I think about existing tunnel underwater, such as a Dover tunnel between England and France. That is underwater tunnel already. And I know that the Dover tunnel is made of 2 floors. Upper level is for the automotive cars, and lower level is for train. If I'm correct, then we can think of that we can replace that train part into Hyperloop.
Yes.
Then we don't worry about the pressure outside, because the pressure should be same as air inside the tunnel already there. That way, if I try to build another one, then I may try that kind of strategy. The tunnel first, and then inside the tunnel, I will put Hyperloop tube separately. That may be the easier and also maybe not cost-wise. I don't know, but that is my understanding. Then the problem is it is not related with the ocean. The same as Hyperloop above the land, right? Technology-wise, then how we can relate with them with the ocean technology. So then I as a two suggestion for that kind of problem. If we separate out of tunnel and then also Hyperloop in terms of technology, one is you may focus only on submerged tunnel, not Hyperloop, only submerged tunnel, because you are more interested in structural design. That is one suggestion. Not the other way is the other suggestion is you just focus on economy of that system you are thinking of, so that you may replace with some kind of ocean transportation system using this technology. So that may be more oriented to economic evaluation. I mean, because I cannot imagine what can be the competition to existing ocean-based transportation system to this one, because it is very high speed. So I cannot find any competition. This level is different. I don't know, but I may be wrong. So you may focus on the kind of subset. Still, because you may find it is difficult to find a relationship with the ocean environment we are talking about in this class. Yes. With the height. All right, thank you.
Thank you.
All right, continue, please.